Working with real robots is challenging. Testing real systems can be expensive or unsafe. Simulation is a solution to these problems. Our domain is off-road Lidar simulation. It is motivated by outdoor autonomy missions. We use a hybrid geometric representation of the world. Ground is represented by a triangle mesh. Vegetation is represented by ellipsoids. Each ellipsoid is associated with a Gaussian distribution. Our simulator is constructed using real LiDAR data. Here is a walkthrough. We collected data from an off-road site in a training section marked in red. We used a custom platform built at NREC CMU. It had a Velodyne 32 LiDAR sensor and a pose system. Camera frames from the training section. Note the uneven ground and different types of vegetation. Offline, LiDAR data is processed into a point cloud. Geometric elements are then fit to the point cloud. A surface is fit to ground points. Non-ground points are clustered into ellipsoids. Simultaneously, we perform semantic segmentation of the point cloud. Vegetation classes are trees and shrubs of different sizes. Information from modeling and segmentation is put together. For each class, this gives us primitives. The set of primitives from the training scene is a library. New scenes can be composed using the library. We performed data-driven evaluation of our simulator. Data was logged in a test section marked in red. Camera frames from the test section. The simulated test world in our approach. Note that the objects are not fit to LiDAR data from the test scene. They come from the library obtained from the training scene. Our baseline was a mesh model simulator. The primitives were open source 3D models. It is representative of a general purpose robotics simulator. Example simulation. The LiDAR points at a tree. The real ray is in blue, simulation in red. Our approach on the left is closer to reality. Open source models are often designed to look visually real. Our primitives, by contrast, are optimized for realistic simulation. Our approach generalizes better to simulating new scenes.